Good afternoon. This is our next example from chapter 6, still looking at method of joints. The problem number is 6.14. So I've drawn the free body diagram already. Point A, there's a smooth pin support. So reactions for smooth pin are in the horizontal and vertical direction, and there is a roller at point C, perpendicular to the plane, so CY. So as has been customary for us, we'll start with looking at the free body diagram of the entire truss, and then we'll go from point to point. So let's see what we've got going on today. Well, so an easy one is starting out with summation of the forces in the x direction. There's only one, so AX is equal to 0. Look at forces in the y direction. So we've got an AY plus CY minus 5 kip equal to 0. So two unknowns, one equation. That's not going to help us out very much. That directs us or pushes us toward the idea that we need to take the moment about some point. We can choose either point A or point C. I'm going to choose point A. Quickly going around the bend, AX is a non-player. Its force is directed in the line of action of the point that we're about rotation. AY is a non-player. P is a player. P is a player. Five kips. Some distance. So we're going to have to calculate the distance between point A and point D. And CY is also a player. We're going to have to calculate the distance between point A and point CY. So we're going to have to find a couple measurements. So I've got them blocked out up here. We need the perpendicular distance between AY and CY, and we're going to need the perpendicular distance between AY and point D. So let me erase those dashed lines so we have a little bit of room to work. So looking at this, I think what we can do, this is my plan anyway. I want to look at that triangle, right? So looking at the triangle with the blue legs and then the large or the long orange hypotenuse, we can glean a couple things from that. The first one is this angle here. So this is a 65-degree angle. This is a 90-degree angle, so 90 minus 25 is 65. This is a 90-degree angle. 90 plus 65, 180 minus 90 minus 65 makes this one a 25-degree angle. 25-degree angle. So if we knew how long the hypotenuse was, we could get how long this long angle down here is. So what do we know? We know that this is a 90-degree angle and this is a 90-degree angle. I have an angle here and I have 10 feet there. So the distance from AY I'm sorry, for point A to point D would be 10 cosine 25 degrees. 10 times cosine of 25 degrees. And 10 times cosine 25 degrees is 9.063 feet. And I also have on this other triangle over here, that from D to C is also 10 cosine 25 degrees. So it is also 9.063. 9.063 times 2 is 18.126. So the length of the entire hypotenuse from point A to point D and from point D to point C is 18.126 feet. 18.126 feet. Here's our 25-degree angle in the corner, which means that we can find this long leg is 18.126 feet times cosine 25, which is equal to 16.4277 feet. So from point A to point C is 16.4277 feet, which we're going to need. We're going to need. We remember how we got into this, right? We got into it because we're trying to get the moment about point A, and we needed some distances. Okay. We also need the distance from point A to point D. What if we took this triangle the triangle whose hypotenuse goes from D to C, which we know is 9.063 feet. Drop a perpendicular down. We know that angle there is 25 degrees. So we could go 9.063 times cosine 25 degrees. And if we did that, that'd give us a measurement of, you guessed it, 8.2139 feet. So from here to here, 8.2139 feet. If I subtract 16.4277 minus 8.2139, we would get the measurement from, or the perpendicular distance, the horizontal distance between A and D. So I'll write it over here so we have it. 16.4277 minus 8.2139, which is equal to 8.213, 8.21. That's a handwriting mistake. 8.239 feet. So this is also 8.2139 feet. Okay. Makes sense. I mean, it is symmetrical, so it does make sense. All right, and we needed all that so that we could plug in the distances into our summation of the moments around point A. So perpendicular distance between point A and the 5 kip force, 8.2139 feet. And perpendicular distance from point C to point A is 16.4277. So 16.4277 feet. Let's go grab our rotation direction. We're at point A. Point B is pulling down, causing a clockwise rotation. Clockwise rotation is negative. And point C is pushing up, causing a counterclockwise rotation. That is a positive number. All right, I took a quick pause to punch everything into the calculator. Negative 5 times 8.2139 is negative 41.0692 kip feet. Add that to both sides. Divide both sides by 16, 4.277 feet. We get that CY is equal to 2.5 kips. It is a positive number, which indicates that I have the direction correctly annotated on my free body diagram. And from the summation of the forces in the y direction, if CY is 2.5, then AY is also 2.5 kips. I'm gonna pause the video and go ahead and erase all the stuff that we no longer need so that we have room now to take a look at the internal PR method of joints looking at. Okay, so our responsibilities again now are to determine the force in each member, then determine whether we are in compression or in tension. We simply need to pick a starting point. I'm going to pick point A, really no reason for it other than I want to. So let's see, point A has AX, which is 0, has AY, which was 2.5, has some force AB, and has some force AD. This was AX equals 0, AB, AD, and AY, which we know is 2.5 kips. I'll put point A up here, or A in a circle to indicate that we're working with point A. Well, I mean, a couple things that we need to take care of. One of them is it's a fact that AD has a X and a Y component. So I think what we've been doing is something like this. Having a hard time getting that bad boy to come out. No problem, we'll erase it and start over with that. There we go. Still a little short. Hopefully third time is a charm. Yep. All right. So this is AD. That's 25 degrees. If that's 25 degrees, then the X component is AD cosine 25 degrees. The Y component is AD sine 25 degrees. So we'll probably need that. All right. let us begin. So let's see, summation of forces in the x direction. So in the x direction, we have AX is equal to 0. I'm not even going to put that in there. We have AB going in the positive direction. We have ADX, which is AD cosine 25. That's it. Equals 0. Oh man. Two unknowns, one equation. That's right. There are other ones to choose from. AY, for example. AY we have is positive 2.5 kips. That's then ADX is negative AD sine 25. It's equal to 0. Add AD sine 25 to both sides. We get 2.5 kips is equal to AD sine 25. Divide both sides by sine 25. And we get that AD is equal to 2.5 kips divided by sine 25. And I think that gives us that AD is, I have 5.916 kips. 5.916 kips. Now our arrow is pulling away from joint A. Pulling away from joint A. We got a positive number for 5.916, which means that I took a good guess on which way reaction was to member AD, and since it's pulling away, that is an indication that it is in tension. So AD 5.916 kips in tension. We can go back and use 5.916 in the summation in the x direction. So AB, oops. Plus 5.916 cosine 25 is equal to 0. And if we did that, we get that AB equal to negative 5.916 cosine 25. Calculator real quick. 5.916 cosine 25. We get AB is negative 5.3617 kip. The negative is an indication that I have AB in the wrong direction. Doesn't mean the force is negative, just means I assumed the wrong direction for the reaction. I'll make a correction with that. Okay. And go back and update my card. 5.3617 kip, and it is in compression. It is in compression because the force vector is going into joint A. It is a reaction to the compression in joint AB. I'm going to pause a minute while I erase the board. I'll be right back. So I've just spent the last 10 or 15 minutes trying to figure out maybe what the best approach was moving forward. You know, I'll draw it up here, then we're going to erase it. If we chose to start with the point D, we have the 5 kip force going down. We've got AD at 5.916 kips. We're looking for DB. We're looking for DC, the arithmetic gets to be a little crazy because of the number of forces that we have in an angle, you know, because eventually we would need to get the, oops, that's not probably not deserving of what I have there anyway. You know, we would need to get ADY, ADX, DBY, DBX, DCX, and DCY, and come up with all the angles. And eventually I ended up with two equations with two unknowns and system of equations. Now, we could go that route, but I was wondering what would happen if we rotated the X and the Y axis. Okay, so at point D, what if we did this? This would be DC. This would be AD. Continuing to rotate the axis, this is DB. And our 5 kip force is right here. And what we've done is we've rotated the axis 25 degrees. And by rotating it 25 degrees, much simpler arithmetic. So that's going to be how I finish out the problem. So still need to quickly grab X and Y component for our 5 kip force. So 5 kip, this is 25 degrees also right here. That makes this 5 cosine 25 degrees. This is 5 sine, sine 25 degrees. 5 cosine 25 is 4.5315. 4.5315 kips. And 5 sine 25 is 2.1131. Now let's take our summations. Summation of forces in the y direction, negative 2.1131. That's not correct. It's negative 4.5315 kips. And plus dB is equal to 0. Well, that was very simple. dB is equal to 4.5315 kips. Go ahead and put that up here. 4.5315 kips. I have a positive number, which is the indication that I have guessed the direction correctly. The force is pulling away from the joint, indicating that that is in tension. Summation of forces in the x direction. We knew 5 AD, 5.916 kips. Forces in the x direction is equal to negative 5.916 kips plus DC plus the x component of the 5 kip force, 0.1131 kips equal to 0. So let's see, what would that give us? Negative 5.916 plus 2.1131. We ended up that DC minus 3.8029 kips equals 0. Add that to both sides. DC is positive 3.8029 kips. Positive, which is an indication that I have the arrow in the correct direction, pulling away from the joint, indication that the member is in tension. It really brings us down to just one piece left, BC. BC. So let me take a small break and I erase what we don't need on the board. I'll be right back. All right, thank you for your patience. We now are going to hop down to joint C. Joint C. So that worked out pretty well for us. So what if we do it again? What if we rotate the x-axis again? 2.5 kips. That's equal to C. That is CB. This is CD. We just found CD, 3.8029 kips. CB we're looking for. We know this is 25 degrees. Go up here real quick and sketch out what that forced triangle would look like for CB. So CB, 25 degrees. CB cosine 25 is going to be our X. CB sine 25 is the Y. Let's see what happens. CD was in tension. All right. So summation of the forces in the X direction. We've got negative 3.8029 kips. CD we have going to the left. Let's see. So initially I had CB going that way, so that means that X to the left also. I think I think I guessed incorrectly. So negative CB cosine 25 equal to 0. Add 3.8029 kips to both sides. Negative CB cosine 25 is equal to 3.8029 kips. Divide both sides by cosine 25. Well, negative cosine 25. CB is equal to 3.8029 kips divided by negative cosine 25. And we'll put that in the calculator, divided by 4.196. I think I have something wrong. I think this should have been probably the same as AB. Let me pause and see what I've got going on. Well, as you guys and gals probably figured out, I've made a couple errors here. I am not going to retape the entire video. What I am going to do is put a big X here, a big X here, right here, incorrect. When you erase all this stuff and redo point C. All right, we are set to go. Starting with the free body diagram at point C. Remember, I'm rotating the axis 25 degrees in order to get CD horizontal. And we know that one, 3.82029 kips. That puts CY, which is equal to 2.5 kips, at 25 degrees. And that is BC or CB. This is also 25 degrees. Also 25 degrees. All right, so let's I'm just grab up here so we can get all my stuff annotated the right way. CB, 25 degrees. So CB cosine 25 for the X component. CB sine 25 for the Y component. We'll go ahead and grab the X and Y for our CY down here as well. So CY 2.5 kips. This is, if this is 25 degrees here, that makes this 65 degrees. So 2.5 cosine 65 is 1.0565 kips. And this is 2.5, you guessed it, sine 65, which if you do the calculation for that, 2.2658 kips. That should give us everything that we need. I'm gonna look at summation of forces about the X direction. So CD is definitely in the X direction. So negative 3.8029 kips. CY is in the negative direction. CX, I'm sorry, negative direction. 1.0565 kips. And I have CBX indicated the negative direction. We're pretty sure that's going to end up wrong. All equal to 0. Combine these terms, they're like negative 4.8594 kips minus CB cosine 25 is equal to 0. Add 4.8594 kips to both sides. Negative CB cosine 25 equal to 4.8594 kips. Divide by both sides by negative cosine 25. You get the CB is equal to negative 5.3618 kips. Negative is an indication that I have the arrow going in the wrong direction. Big surprise. The arrow should actually be going this way, which is an indication that CB is in compression. Because the arrow is pushing into the joint, which would be the reaction to member CB being in compression. There we go. All right, that's the end of problem 6.14. We picked up a couple things in this problem. So earlier on, you saw at point D the advantage of rotating the axis so that we ended up with just one angle. If you didn't do that, you ended up with a system of equations which was a mess. That's what made me think to do that, right? So I backed away, started working the problems. I'm 10, 15 minutes in the calculation, and I've got angles all over the place. I'm like, stop. What if we rotated the axis? So that's what we did right there. Hope you guys are having a fantastic day. Talk to you soon.